So my name is Clay. Today I'm going to be taking you through my talk, the evolution of deep linking. A little bit about myself. I actually just started developing in 2013 when I did my undergraduate at Stanford. I just recently graduated Stanford a couple months ago with a bachelor's in computer science, and just recently started at Branch, actually last month. So, I actually have an interesting story of why I'm here on the last slide. You may have seen that I started a mobile application company in 2015. And through that mobile application company, we had our own struggles with deep linking. And that's kind of how I got to know Branch, and as we kind of went through that struggle. So I'm going to take you through that process that I had through deep linking. So what's Goodly? What's Goodly was my mobile application company. It's social polling for college students. So what that means is you post a question with 2 to 4 answers anonymously, and anyone can vote on whatever answers they choose, and you can gauge interest or gauge opinions on your peers. Now, this was during elections, around the election time of 2015, and we had a lot of interesting press. A lot of our polls were being shared in different articles. People were posting them all over social media, saying, wow, look at how people at Stanford are feeling about this certain topic. And this spread to multiple other campuses. We had about 100 campuses that were using What's Goodly. And we ended up seeing a lot of traction, a lot of word of mouth virality. Now, the issue is when people were sharing our polls through these different mediums of social media and these different articles, they would normally just take a screenshot of the poll and post it, and there was no way for users to actually navigate themselves into our application to see this poll, right? So it was pretty obvious we needed some sort of sharing solution, right? It wasn't, native applications weren't the same as the web. You couldn't just generate a link for a poll and share it to a friend and expect that they have the same experience. So we came up with a couple solutions. Our first solution was we just avoid a sharing solution, and we continue these marketing campaigns and kind of just push the same channels that we were already pushing. Or we could build a web version. Now, the web version wasn't the fastest solution. We were completely native at the time. We had a bootstrap jQuery front page website that really didn't have the same capabilities as our native application, so we really decided that wasn't the route we were going to take. And then there was these things called URI schemes. This was back in iOS 8 before universal links and everything. So we decided to start researching into these things called URI schemes. So as a refresher, what a URI scheme is it pretty much just tells the browser what to do with everything after the colon. So if you type in on your browser file : / and then a local file path, it's going to tell that browser to open that local file. Or if you use HTTPS, it's going to tell the browser to establish a secure connection with the server. In iOS, this is the same. They have the same type of guidelines. They reserve things like HTTPS for Safari, URI schemes like Mail to for their mail application, but they also allow you to register your own URI schemes for your own applications. For example, if you registered an application with the URI scheme My App, then any URL that was clicked with My App as the URI scheme would open up your app. Now, this looked like a perfect solution. We took What's Goodly : / and we appended poll ID onto the end of it, and it would open up our application, and we would see the poll that we wanted to present. So we had these links that were working, and they were bringing users to the right content. And so we were ecstatic, right? We were so happy that we'd taken the time and solved this deep linking issue. Now, this lasted for about 10 minutes until we asked ourselves what would actually happen if a user did not have the application, right? what would Safari do? Well, we got this major roadblock in our user experience, right? Safari would take this URI scheme and it would say, okay, which app is registered to this URI scheme? If that URI scheme wasn't registered to any app on your phone, then it would try to handle it itself and obviously wouldn't be able to open the page, right? So there was no way of getting out of this page. You'd have to kind of redirect back to where you came from, and it was just really, really ugly experience. So we sat and we pondered, thinking about how are we going to fix this issue. So what we did is we actually went back to the normal standard web URL. We had users land on our normal web page, and then we would perform this simple try-catch statement that would say, okay, if the user agent is on an iOS device, let's go ahead and try this URI scheme. If it's not registered with the device, then we'll fall back to the iTunes Store URL. And then they would download the application and be taken to the home page. So that seemed like a great solution. As we were building this, iOS 9 came out. We launched What's Goodly in January, and as we're trying to build this sharing functionality, iOS 9 releases these things called universal links. Right? I'm sure most of you are familiar with them, but according to documentation, iOS users can tap a link to your website and get seamlessly redirected to your installed app without going through Safari. If your app isn't installed, tapping a link to your website opens up your website in Safari. Now, the big breakthrough here was that now Safari didn't have to handle your link. Before, with URI schemes, the URI scheme would have, or the URL would have to be passed through Safari, and Safari would have to make the decision on what to do. Now, using universal links, we can kind of bypass that system and go straight to the application and fall back to a Safari experience, a Safari website. So this is how that flow essentially works. You have a normal web URL, and then it gets processed through what's called the Apple App Site Association file, and you host this on your web domain at whatever your domain is / Apple App Site Association file. And this file, I'll get into it in a sec, but I'm actually just going to take you through kind of the process of what would happen if the user clicked on the link. So, for example, this is Airbnb. Airbnb, if you were to share let's say this treehouse here, send a link to your friend. When that friend clicks on that link, they're going to be taken to this ASA file, right? And this ASA file is going to determine what direction that the client is going to take. So, what this Apple App Site Association file looks like, it was actually used previously, but in iOS 9 was when they actually began using it for the universal links. Now, you have a section called app links, and you can, in the details section, it's just a normal JSON file. You can specify all of the application IDs that you want to associate with that website. So, for example, if this was hosted on Airbnb.com, you would see that they would have their app prefix and their bundle identifier that says that, okay, we want our application to handle these specific paths. And in your paths array, you can see, if you have path treehouse, then you know that this app is going to handle treehouse. But you can say not igloo, and then you'll know that anything that's associated with igloo is going to fall back to Safari, right? So you can also use wildcard characters, to specify essentially any path that you want. Now, if the app is not installed or not handled by the ASA file, you're going to be taken to the web version. So in the case of Airbnb, it's going to look something like this, just whatever the web version of their application is. And if the app is installed, you're going to be taken to that PC content. The universal link will essentially bypass Safari and take you directly inside the application. So this is what happens. Once the universal link is clicked and the ASA file determines that your app is going to be the one handling it, there's this function in your app delegate called application. You continue user activity with this restoration handler. And what you can do is you can take that user activity object and you can see what type of user activity that is. And in the case of universal link, it's going to be this browsing web type. And then if that's the case, then you can store that into a URL, parse that URL, and determine where the user needs to go within your application. So, for example, we can pull this URL out, we can parse it into airbnb.com/treehouse, and then we know that we're going to be taking this user to this treehouse. And this is the result. You end up in the native application flow, actually seeing the treehouse, right? So what's the difference? Well, in my case at What's Goodly, we didn't have a fully built out web version. With universal links, you need to ensure that every single URL that you want to process can be handled by your web app. So if you're native first, and the user has not installed the app, you're going to be falling back to the web version, and you need to ensure that there's some way that your web version can handle that URL, that path, right? And what we've also found is that retention and conversion is so much higher when you're on native. I'm sure a lot of you are familiar with this, but I just recently actually did a study with a lot of our branch users using a 1-month retention rate of native apps versus web apps. And we saw that actually 60% of users were likely to come back to the native app, whereas those same users that landed on the web app were only had 11% chance of coming back to the web app. So, how can we convert users to this native experience, to our native application without compromising this experience? Right? How can we convert these users? In the case of universal links, the ASF file will drop you back to the web version, but there's really no immediate way to route back to the native application. There's nothing that's really pushing us towards this native application, right? It's kind of a 50-50 split. And if you don't have the app installed, you're most likely only going to be interacting with the web version, unless you have something like deep views or banners supported. Now, you could also do a hack similar to what we did in the URI schemes previously, where we'd say, okay, we're going to default if we hit if the ASF file tells us that or the app is not installed, and we're taken to the web version, what we're going to do is perform some sort of JavaScript redirect where we can then shove them back to the iTunes store, right? This is really, really hacky, and personally, I don't even know if this hack would still work. This is what we use for URI schemes, but what ends up happening is even if you do redirect your users back to the iTunes store, there's no way of actually passing that metadata through the installation process. So what happens is your user experience is completely compromised. So in this example, if you had target.com/purse and you were trying to see this purse that you clicked on, if you went through the installation process, that purse would not persist through the installation, right? So, or you can use branch for deferred deep linking. What is deferred deep linking? Really what it means is regardless of the direction you take, whether the app is installed or not installed, you're going to see that purse at the end of your experience. And how does this really work? Well, what we do is we take a normal web URL, and if the user goes through the installation process, we take all of that information that's associated with that web URL, and we route it around the iTunes store. So when the user opens the app for the first time, they receive all of that information, and then you can then take them to the right place to show them that purse. So this is what branch links look like conceptually on the inside. The important things here are, what is the context? So what do you want to show the user? Are you trying to show the user that treehouse or the purse, whatever it is? But you also want to know where that user came from. Because you can't pass any information through the installation process, you don't know whether your users coming from Facebook are converting into signups or whether your users from SMS are converting to signup. So this allows you to say, okay, these are the channels that are actually successfully converting users, right? So how do we do it? How do we do this deferred deep linking magic. This is, our method 1 is called snapshotting. So how this works is a user clicks this normal web URL, and we generate a fingerprint. A fingerprint consists of the IP address, the screen size, the operating system version, among a lot of other parameters. Okay? And then we store that in our server, and once the user passes through the installation process, we generate, and they open the application for the first time, we generate that same fingerprint using things like their IP address, screen size, operating system version, and we try to match the two. So we say, okay, this person that clicked on this link has this fingerprint, and this person that just opened this application has an extremely similar fingerprint. We're probably going to match these two, right? And there's some cases where it fails, right? So we all might be using the same iOS device, and we may be coming from the same IP address because we're on the same Wi-Fi right now. And in that case, there are edge cases where we can't say that this is perfect, but in most cases where you're probably the only person on your IP address making that request at that specific time with that specific device, it's going to work. And then what we can do is, once that match is made, we can say, okay, let's pull all that information that's associated with that link, and let's present that to the user. And then let's also attribute that user. Let's in our analytics, let's say, okay, this is where that user came from. Now, our method 2 is the SFSafariViewController. Now, this is very similar to device snapshotting. What we do is we will, if a user is in Safari and they click on the web URL, we'll actually store a unique identifier in the cookies of Safari, and we'll save all that. We'll save that cookie ID associated with that link ID in our server, and then once the user passes through the installation process, we'll then open up an instance of a SafariViewController, and we'll pull that cookie back out, and then we'll match it with the original cookie that we stored when they clicked on the link. That way we can pull all the information down and say, okay, this is the experience that this user needs to have. Now, our third method, and probably the one that we're most proud of, is our memory-based matching. And this is why branches is important. Sorry, actually going back to the SafariViewController. This is actually being outdated in iOS 11. So the Safari, opening an instance of the SafariViewController and pulling out the cookies won't work anymore because they're actually separating the cookies between the two. The instance of your SafariViewController is going to have its own cookies that are isolated from the Safari application on your phone. So there's no way to actually pass information through. Now, our third method, going back to memory-based matching, how this works is we make these matches, right? We make these pairs between users, and once we store that cookie in their browser, and once we can pull this IDFA, which is this unique identifier used for advertising purposes. Every iOS device has their own IDFA. It's always unique, and we can pair that up with the cookie that we store in the browser, and we can just associate that with a persona, right? So we can say, okay, now that this person is in our database, we know that this cookie matches with this IDFA. So what we can say is if that match was made during this person opened Airbnb, and we made that match when that person opened Airbnb, now when they open any other application in the branch network, we can say, okay, we have this IDFA, and it matches to this cookie, and this cookie is the same cookie that's associated with the link that they just clicked on, so we can make that pairing right there. So any application in our network can utilize any match that's been made previously. And with the 27,000 applications that we have in our network, this becomes extremely powerful. And so unfortunately, in deep linking, because iOS is now getting rid of the SafariViewController, it's becoming increasingly more difficult to make these matches. And having a large third party that can handle this memory-based matching is essentially going to be one of the only ways that you can really accomplish this. So now that I've kind of taken you how we work and how we make these matches, I'm going to take you through a quick tutorial of how you integrate with Branch. It's very simple. You sign up on our dashboard and you input your URI scheme and your fallback URL. You can actually fall back to iTunes Store. So unlike universal links, where there's no obvious way to get to the iTunes Store, we actually allow you to fall back to the iTunes Store, or you can provide your own fallback URL to your web domain. And then you input your universal links information, which all we need is your bundle identifier and your Apple app prefix. And we actually create that ASA file for you, so you don't need to host that file on your own web domain. If you don't have a website, we can handle all of that for you. If you do have a website, we host all of our applications, Apple app sites, in-house for them, and do all of that handling. And then once that's done, once you've configured your plist to take our branch key and you've enabled universal links on your Xcode project, which take no more than a couple minutes, what you'll end up seeing is when you generate links, when you click on links, we pass everything back through this did finish launching, the app delegates did finish launching function. We call this init session with this callback, right? And so anytime a branch link is clicked on, you're taken back to this callback in your app delegate, and you can do whatever you want with that data, right? So you can store that data in a model and use it anywhere within your application, or you can just use it for simple navigation. So why branch? Well, everything we covered today, all of this deep linking service is actually provided free. It's free on the web, and we believe that it should be free for mobile developers. What we charge for are premium products like our banner solutions and our email solutions, but our main solution that I just walked through today is free. We are very developer first, very developer friendly. I myself was a small startup, and the way that Branch treated me and the way that they really helped our application grow is the reason why I'm now working for them today. And for the obvious reasons, we have a massive network of applications. 40% of the top 200 applications on the App Store use Branch, and that network is something that you can leverage within your own mobile application. So I highly recommend integrating with us. We're out at a table outside. We have an integration challenge. If you want to win a free hoodie or sign up for a newsletter, you get a free t-shirt. But anyways, thank you. Start today. You can feel free to email me any questions at cjones@branch.io or tweet at us at branchmetrics. So thank you. Yeah, so the question was, with security concerns, whether you have very private information, how does Branch handle that? Right? So we take security very seriously. All of the information that we accumulate from your user base stays strictly on our end. So none of that is distributed. All we do is we make that matching for you. There's no sharing of information between any of the networks. All we're doing is saying this device IDFA is associated with this browser cookie. We don't take any of the actual user information, and that's all up to the amount of information that you pass through the link of your user, right? So all you need to really say is, okay, this user is coming from Facebook. We want to give them this experience, or we want to make this attribution. You don't have to pass all that information through the installation process, right? We have different events that you can keep track of, but it's really up to you the information that you actually pass through to us. We're not going through your app and scraping out all that information. So I hope that answers your question. Any more questions? No, it's not, but I will post this, and I can send that out. I guess come to our table afterwards, and I can get you something with it, yeah.
So I would assume that there's situations where people will get led to a screen on the App Store, so that at that point you take note of like who it is, their IPA. Assume they don't download the app, but then later on they go download the app. What's the amount of time before you expire like, that IPA so that people are downloading the app 2 weeks later and then it tries to remember that where they click from 2 weeks?
Yeah, that's a great question. So our links actually have a customized match creation of however long you want it to be. We default that to 2 hours, and we found none of our partners, none of the people we work with actually really change that, just because we think it's a fair bet if the user's coming to our application within 2 hours, they're the ones that are originally coming from that link, and then we just expire it. So yeah, we have a customized match creation. I guess to answer your question. These are great questions.
Any plans to integrate with cross-platform toolsets like React Native?
Yes, so we have solutions for React Native, Cordova, Ionic. I have to check the website of all the platforms that we use, but yes, we do integrate with cross-platform solutions.
Is it possible for you to be aware of what kind of device you're on? Because like every situation, if we're on an iPhone, we want to go to the App Store. If you're on a desktop, we want to go to the regular website. Do you support that?
Yes, we do. So through our whole, I only went through the iOS today, but through our whole dashboard, you can set preferences for your iOS fallback URL, your Android fallback URL, Microsoft phone URL, Amazon Fire URL. We cover pretty much any device, and if we don't recognize your device, we have a further fallback URL that if we don't recognize it, we give them that URL, or we fall back them to that URL. If they're on desktop, we actually have a couple options. We can direct the user to whichever website you would like to direct them to, or we actually have a customized text me the app page. So if you don't have your own web domain, we'll host it for you. If the user clicks on your link on desktop, we'll provide you with a text me the app page where you put in your phone number and they send you a branch link, and then the context all the way through that desktop to click all the way through the text me the app is maintained, I guess. So yes, we have pretty much solutions for any case, and it's all customizable. So.
When you were talking about fallbacks, will it also fall back to like the method 1 you mentioned?
So you're saying snapshotting?
Right, yeah, like the probably match compared to, the more advanced memory matching.
Yeah, so if there is no memory match made, then we take the fingerprint too, and we take the cookie, right? And if they pass through and they don't fit the memory-based matching, then we'll attempt them at device snapshotting. All right, well, if anyone has any extra questions, feel free to come up and ask me. I'll be here for a while, but I don't want to keep us all here. So thanks again. I appreciate it. See you soon.